In this, our second lesson, we'll be looking at an area that many gardeners are curious about. This area is plant identification. We'll also be looking at one of the tools used to help with plant ID. A dichotomous key can be used even by novice master gardeners to help identify a plant. Homeowners are often curious as to the proper name of weeds, flowers, trees, and other plants they find in a landscape. You may be called on to identify a plant. Don't worry, you'll have help with that process. A plant key can be very helpful, as can other master gardeners and your extension agent. We also have personnel on campus who are experts at identifying plants and are available if needed. Plant characteristics are very important in identifying plants. Noting some basic characteristics can go a long way in helping us with identification. Let's look at trees. Trees are either opposite-leaved or alternate-leaved. This is called the leaf arrangement. Opposite-leaved plants have leaves directly across from one another. Alternate-leaf plants have leaves that alternate on the stem in a stepwise fashion. This characteristic can help you separate different groups of plants such as oaks and maples. Oaks are alternate-leaved and maples are opposite. Let's notice some things regarding the oak photo. Note that the leaves may look opposite if you're only brought in the very tip of this twig. If you want someone to bring in a sample, have them bring in at least 6 inches of the end of a branch. I want to show you something else while we are here. How much current season's growth do you see on the oak? In other words, how much of this twig grew this year? This is a little tricky with this example because you have the very end of the twig being green, with older growth brown. Remember this. This is important. Leaves are only attached to current season's growth. So all that you see in this photo is current season's growth. The green section of growth is due to what we call a secondary flush. The growth before the green section formed in the spring and a secondary growth in early summer. This happens fairly often on trees such as red oak. So which is more common? Do most trees have alternate leaves or opposite? Actually, most have alternate leaves. As a matter of fact, few tree species have opposite leaves. Let's look at those. To remember the major groups of trees that have opposite leaves, remember mad buck. Mad stands for maples, ash, and dogwood. Buck stands for buckeye. So if you find a tree with opposite leaves, it'll likely be one of these species of trees. There are other trees with opposite leaves, but they are less common. Another important characteristic is whether leaves are simple or compound. The top row of leaves are all simple and include elm, red oak, and linden. The bottom row are compound. Each of these photos is of a single leaf except the center one, which has 2 leaves. These trees are pecan, honey locust, and white ash. So a compound leaf is made up of several leaflets. So how do you tell the difference? How do you know that what looks like a compound leaf isn't just a grouping of simple leaves? Look for the bud. A leaf will always have a bud at the base of the leaf. This is an example of a simple leaf. This is a green ash, which has a compound leaf. Notice no bud is at the base of a leaflet. However, there is a bud at the base of the compound leaf. Now this is Kentucky Coffeetree, which has what we call a bipinnately compound leaf. This photo is of one single leaf. There are no buds in this photo. This entire structure is one leaf and will be shed during the autumn. Kentucky Coffeetree has a nice shape but is messy to clean up in the fall due to the large leaves. Also, female trees have pods that I think are unsightly. The photo in the lower right is one of the seeds contained in a pod. If you buy a male tree, you can avoid the unsightly pods. We mentioned before that clients should be asked to bring in the end of a stem rather than a single leaf. Though sometimes a single leaf is enough, having more of the plant can make identification much easier, as you can tell whether the leaf is simple or compound, and whether the arrangement is alternate or opposite. Let's look again at our oaks and maples. You can tell the difference between the two even if you only have a single leaf. Oaks have pinnate venation, and maples have palmate. Pinnate venation means the leaf has one central vein with smaller veins coming off of it. Palmate venation has major veins all arising at the base of the leaf. The central vein is not larger than all others. Other characteristics that can be used to identify a plant include leaf characteristics such as overall shape, shape of the tip, base, leaf margins, and whether the leaf has lobes or sections. Even the leaf margin can help, as there are a number of different patterns that are helpful in ID. You do not need to know these terms, but realize they are used in identification. Bark appearance can also be helpful. London plane tree and sycamore are very similar trees as they are closely related. As a matter of fact, another name for sycamore is American plane tree. One of the ways you can tell the difference is that London plane tree exfoliates its bark to near ground level, but sycamore keeps its bark up to at least 10 feet. So this is a listing of the characteristics of a tree that can be used for identification. The one we didn't mention thus far is the last one, fruit and flowers. They can be extremely helpful, but may not be present on the plant at the time of observation. Also, there are little tips you learn over the years that will help with ID. For example, forsythia has a hollow pith, and walnut has a chambered pith. In addition, if you chew on a walnut twig and then spit, your spit will be yellow. We mentioned using a plant key earlier. Specifically, we'll look at a dichotomous key. With a dichotomous key, we choose between two choices for one characteristic for each level. For example, how do you tell the difference between an oak and a maple? The characteristic you choose is leaf arrangement. So we have a portion of a dichotomous key in this slide. This one is just for oaks. It is simplified so that you can see how the key works. The characteristic we look at first is the leaf shape, specifically where the leaf is widest. You have two choices, both marked by a number 1. If the leaf is widest at the top, it is a blackjack oak. Note how the blackjack oak is widest at the top of the leaf, making it unique among all the oaks listed in this key. If the leaf isn't widest at the top, then move to number 2. If no lobes, then you have a shingle oak. There are actually other oaks that do not have lobes, but we are keeping this simple. You can see an image of shingle oak and red oak in these photos. Many people think that lobes are found on all oaks, but they are not. If there are lobes, you move to number 3. This choice is based on whether the leaf has bristle tips or not. You can see an example of a leaf with bristle tips on the pin oak and one without on the English oak. Oaks with bristle tips belong to the red oak group and include red oak, pin oak, scarlet oak, and others. Those without bristle tips belong to the white oak group and include white oak, bur oak, post oak, chinkapin oak, and others as well. If you have bristle tips and 3 to 4 lobes, you have a southern red oak. If 5 to 9 lobes, then black oak. If you do not have bristle tips and 7 to 11 lobes, you have white oak. If 3 to 6 lobes, then post oak. As you become more familiar with trees, eventually you'll be able to recognize certain trees at a distance. Others will require more detailed examination. If you're interested in tree ID, an excellent resource is a small booklet from the Arbor Day Foundation titled, "What Tree Is That?" Well, that ends our second lesson for plant growth and development.